Hello. So I'm starting a new project using these Angel Tears lights available from Cool Neon. And you can see I've already started to take this apart. It's basically an LED chain. It takes 3 AA batteries, so 4.5 volts. And I'll turn it on. I don't know if it is better with or without the lights. But it makes a nice light, a kind of purplish whitish light that I like a lot. But I don't like the fact that it just goes on or just stays on and you can turn it off. It has a little switch. I'd rather have something a little bit more dynamic. So what I thought I would do is take this apart and work on making these fade in and out. Since I don't like blinking, I kind of like the fading effect. So what is my plan for doing that? Well, I'm going to adapt a circuit that I've used before. Let's see if I can zoom in on this. It's a triangle wave generator and an amplifier. So here's the triangle wave generator, and this is an amplifier, just so that I can get this back up to the full range of the sweep of the op amp. So I have a bunch of LM358 op amps laying around. I got kind of a tube of them, and you know, it's good to have them around for analog projects. It's a good general purpose op amp, and it doesn't go all the way to it can't emit all the way to the V positive. It does go all the way down to the V negative. So there's usually a little 0.7 volt difference between the input voltage and the total that it can emit. But it's, you know, still pretty good. You can get ones that are more centered or whatever. But anyway, I'm just going to talk the basic theory of operations of this circuit. So one op amp is functioning as a Schmitt trigger. So Schmitt trigger involves positive feedback. When the voltage coming in is greater than the inverting input, this goes to positive, you know, just completely to whatever the V positive, the maximum voltage it can get out. And when the input is lower than the inverting input, this goes negative. So point A is basically going to be shifting between positive and negative, and positive and negative. And I haven't shown the mechanism by which it shifts, but we'll get to that in the second part of the second block. So the second op amp is working as an integrator. It essentially, if there's any change at point A here, that change will be smoothed out by the integration. So for example, if we go from 0 to 1, then on this side, this will slowly, this output will slowly rise to basically integrate the input signal. So this works because, you know, if you want to get some sort of change over time, you need capacitors. Now I could have put one capacitor in here, a fairly large capacitor, if it was bipolar, but I only had large electrolytic capacitors. So what I decided to do was make a capacitor without any polarity by putting two together. I put the positive ends together, and I use these diodes to make sure that the voltage in here is always greater than the voltage out here, making sure that the positive is always in the middle. You don't have to use these diodes. I've seen a lot of ones where they don't, but I just always feel like there needs to be a way for current to come in here to make sure that that's true, that that part is always positive. So I use two diodes and two capacitors to essentially make a 50 microfarad capacitor right there. And so essentially this is an inverting input, so there's this negative feedback. So what you have when you get to point B is essentially this dotted line. So it's in the opposite direction of the positive, so because it's inverting. So when it's positive, this will go negative, and when it's negative, point B will be rising in voltage. Now, what causes it to shift? Well, the feedback from B is also going into this voltage divider here. So essentially, when the voltage, let's say this is plus 5 volts here, when this voltage gets to be minus, let's see, 1/2, minus 2.5 to 2.7 volts or so right here, then this voltage divider will basically set this point to 0, and that's the transition point where suddenly the polarity is going to switch. Point A is going to transition, and then point B is going to start moving the other direction. So that's why this part is a triangle wave generator, because you're getting a nice triangle wave. Now, finally, the one thing to note is that this is not going the full width from A to B. If you can get closer to the full plus 5 to minus 5 volts in this example, but it becomes less reliable kind of as a switch over here. You might not exactly hit the negative unless you make sure that the resistors are exactly what you want. So what I've done, and this could be tuned. You could do this without this op amp and get wider range, but I wanted to put this in so that I could actually control the amplification. This will max out at going between plus and minus 5 volts in this example, or the V plus to V minus range. But you can do some tuning here with the resistors. So the circuit I'm planning I've planned is basically this circuit with a couple of changes. I'm taking, let me see, this resistor and this resistor, and I'm switching them out with a potentiometer so I can tune them. So this is going to help tune the frequency, how quickly it moves, and this one is going to help tune the amplification, so how bright it gets. The other difference is that the original runs on 4.5 volts. Because I'm going to lose a little bit, oh, and I should say, there's not a lot of power comes out here. That's the other thing. This can only run about 20 milliamps, and what I really need is closer to 10 times that. So I'm also going to put a transistor out here in order to amplify that signal. So amplify the current so that I can actually run the whole chain of resistors, not just one little resistor. But there's going to be, I'm going to use 6 volts instead of 4.5. I'm going to lose about 0.7 volts in the op amp in terms of the full range. Remember, it can't go completely up to V positive. And I'm going to lose a little bit of voltage in the transistor. So that should bring me back down to 4.5 volts, and 6 volts, is nice. It just needs 4 batteries instead of 3 batteries. So I decided to put this together, and let's see what I've got. So I've got a bit of a mess. Let me get this out of the way. So there are 2 op amps here. The triangle generator is here. This is the control for my frequency right here. The electrolytic capacitors and the diodes that I showed on the diagram are right here. So that feeds in to this. There's one op amp basically on one side of this chip, one op amp on the other. I've put them into a mess of wires. I have a voltage divider here to get my kind of ground reference. So this would be plus 3 volts, minus 3 volts, and then ground would be, where have I put ground? Oh, it's along this rail right here. So I've got ground, -3, and +3. And I use the ground. This chip also has 2 op amps in it. I'm using the top op amp, and I have basically set the inputs to the bottom op amp to ground. Or actually, I set one input to ground and the output going into the grounded input so that it won't cause spurious signals. I have my transistor here. I used a PNP transistor. What is this? This is the 29, let me take a look. 2907 is what I think, but I never remember these numbers. Yeah, the 2907. So the good thing about the 2907 is that you can put a fair amount of amperage through it. Yes, 650, 700, 800, I don't know. The way to check it is if you touch it and it's too hot, you're putting too many amps through it. So that's the system I use. And let's see how this works. So I am going to hook my power. Actually, let me set it to 6 volts now instead of 4. Oop. Just setting the power supply. And now let me also plug in the output. I think this was the negative side. It's diode protected, so because it has all LEDs, so this should be fine. And let's see what it looks like. Hopefully, yeah, I'm connecting this in the right way. Okay, so what you can see is, it's fading in and out, which is, here, let me get that back into the frame. Fading in and out, which is what I wanted. Looks pretty good. Let me adjust the frequency here. So let's see, I think this is faster. So it can go, I can make it get close to flashing, essentially. I kind of like it moving a little slower. And the intensity, let's see what I can do with that. I can make it so it's not intense. Oh, by the way, this lowers not just the, this lowers the variation from minimum to maximum. When you completely attenuate it, you'll notice the lights are slightly on. That's because it's kind of stopping at the mid voltage, 3 volts. So you've got a little bit of power going through. But then you make the higher high and the lower low, so it turns all the way off and all the way on as you turn this dial the other way, up until the maximum that the op amp is capable of driving it at. And we do the check. Yep, I'm not being burned, so the circuit's good. Now, obviously, I can't carry this around in the breadboard. This is a nest of wires. So my plan is to put this together on a board into, something that I could potentially put on a costume. I've got a battery pack, 4 AA batteries that I can use, and I've just got to put a connector onto it, onto the board so that I could drive it from this battery pack. So hopefully in the next video or videos, I can show you some progress.